for this success and showing how China main strengths and its a great potential for the future of the drones. So let's first start with the contents of our presentation today. The outline of the presentation today, we have 8 terms today. The first one is the global Chinese landscape. In this module, we will provide an overview of the market size, the competition, growth trends. The second module, we will show the policy and regulation. The third modules, we will show the industrial chain panoramas. For the number 4, the outline, we will provide the drone principles, assembly, and debugging. Number 5, we will provide the detailed application scenarios, and then we will provide the regional coordinated development. Then we will go for the drones future outlook, and finally, the conclusion of our presentation. So first, let's start with the global low-altitude economy market. As you can see from this chart, both the global and the Chinese low-altitude economies are growing exponentially. But China, as highlighted in orange here, is leading the way with an annual growth almost 25%, and exactly exceeding the whole world. For actually this rapid growth is due to many factors. The first one is the technical integration, combining the AI, the artificial intelligence, depends on the 5G terminology, also depending on the IoT, and finally, according to the autonomous flight and advancing data analysis. Number 2 is due to the supply chains dominance, as China leads the world with the most complete industrial chain and also the largest drone fleet across both customer and industrial markets. Number 3 is the national level strategy, as recognized as a key strategy industry. It was featured that the government work report in the 3 sequence year, reaching almost more than 1.5 trillion RMBs by 25. Actually, we have the classification until 25. For the improved regulation, beyond the market size, is the size of China low-altitude economy is supposed by 3 main pillars. The first one is the massive industrial base, shows over than almost 1 million registered civil drones. China is the world's largest application market. Also a clear legal framework at the end of 2024. Regulations on drones management provide a clear rule for drone production. And number 3 is the huge growth potential, as according to the Civil Aviation Administration of China, CAAC. Usually we will listen to this terminology. The market now exceeds more than 3.5 trillion RMBs by 2035. Now let's go for the in-depth policy interpretation. As I mentioned before, the CAAC regulation established a clear framework divided into 2 main areas. The first area is the regularity core, and the second one is the K provisions. The first one, the regularity core, first is the drone classification. The drones should be classified into 5 tiers according to the size. According to the size from micro to large, and also the airspace management, controlled airspace above 120 meters required approval from CAAC, while the small drones have general access below this amount. Number two, for the K provisions, actually, it is mandatory to have ID for the drones, not to work haphazard. The drone must broadcasting their ID in the flight for the real-time tracking. Also for the real-time registration, if every drone is digitally linked to its owner from production until end of the service or until the retirement. Number three is the operator certification. The companies must organize and hold an official safety certificate for the operator. Now, at the local level, actually, both Fujian province and Fuzhou city are actively supporting the drone industry. For your knowledge, in China, many provinces, one of them is Fujian province, and the city we are living on now, which support the industry, is Fuzhou, to be well known for you. So now both Fujian provinces and Fuzhou city are actively supporting the drone industry. Fuzhou now, Fujian province is currently drafting a comprehensive action plan to use its regional advantages. On the local level, we have Fuzhou now launched a three-year roadmap to become a national demonstration zone by 2026. Actually, to achieve this goal, a city is providing a strong financial support and also the land, the market, and the talent support to build and the ecosystem for the drone business. Look at now the industrial chain panorama for this technology. So starting with the, sorry. Okay, starting with the upstream supply chain, Fujian is making the great progress in building a strong and self-sufficient ecosystem with two parameters, the K materials and the core electronic components. The K material must be carbon fiber because the carbon fiber makes from 60 to 80% of the drone structure to reduce the weight. And also it is vital to extending the flight time. We have many cities also here in Fujian. One of them is Xiamen. Xiamen also has become a major natural hub with over 1,100 companies supplying the high performance materials for the drone industry. For the core electronic component, also Fujian companies are successfully developed the hardware for the software and the hardware locally. Now in the midstream drone, midstream drone manufacturing, also Fujian benefit a clear division of the labor. We have many cities here in Fujian provinces, Fuzhou and Guangzhou also, and Zhengzhou, all of them supporting the industry of the industrial process of the drones. Now let's go for the downstream sector completes Fujian drones ecosystem with a strong service, training, and testing capabilities. So let's first try to turn on the attention now to the drone principles, not to talk much about the industry now, the drones principles and the assembly and debugging. Looking at now the multi-motor drones, how it's actually fly and how the control is based on the four fundamental movement almost similar to the propeller or airplane. So first one is the vertical moving. Second one is the pitch. Number 3 is the rule. Number 4 is the yawing mechanism, or how to use the drones. The first one, how to move vertical and up and down and hover. The propellers generally lift against gravity, almost similar to the airplane. So when lift is greater than the gravity, the drones can ascend. And when equal, it is a balanced case. It means only hovers. When less than the gravity, it only descends. The number 2 now. Oh, okay. So if there is any question, please try to write it to me because I cannot listen to your voice. So if you listen to me, should I continue or there is some mistakes? Hmm? No. Still continue. Oh, okay. So I will continue. Okay. So now I am explaining now how the drones can hover in the sky. There is many action. First one, the vertical movement, up, down, hover. Second one is the pitch, which means forward and backward. Forward and backward, how to do that? Actually, to fly forward, the rear propellers speed up and the front ones slow down, tilting the drones forward. Reverse, to reverse this action to fly backward. So now this is the 2 action, forward and backward. Rule, which means left and right. So now we discussed the vertical movement, the pitch movement, and the rule mode. So to fly side away, the propellers on one side speed up while the other side slow down, which means tilting the drones left or right. Now the rotation, we call it in the mechanical engineering yaw. To turn or rotate horizontally, the drones adjust opposite pairs of the propellers using according to the Newton third law of action and reactions. So let's now talking about the debugging assembly. I will leave you now with this video to know how to assemble and debugging for the first part of the drones. So hopefully you can listen to the voice or just try to see what you can watch on the screen. Okay, of course, this is the first step of the assembly, the motor installation. We are trying now to secure the motor to the carbon fiber lower arm using, of course, as a screw. If you want to try again, it is only few seconds. So the first part is the motor installation. and landing the gear attachment, and the post the assembly, the aluminum part. Of course, this is a laboratory module, so can also teach students how to make the assembly and the debugging process. Okay, so let's now move to the central power assembly, and also there is a short video showing the central power assembly process. Of course, for more knowledge now, we have the electronic speed controller installation. We call it ESC, acting as the bridge between the circuit board and the motor. Of course, as you know, the drones usually needs the AC to control the speed, but we are depending on the battery, which is DC. So we have a controller now to modify or adjust the battery DC power until having the AC frequency to control the motor speed based on the flight controller signals. So I also will let you watch this video. Here's actually again, it is also few seconds. So first installing after the motor installation and the landing gear attachment, we are now installing the electronic speed controller and the frame assembly to secure the circuit board to the bottom, and also place the carbon fiber arm plates. This is the assembly number 2. And as I mentioned, this is only the laboratory scale drones for the students, and also securing the wires here using the strap to firmly fix the controller into the lower arm. And also here is, sorry for, okay, here is also another video showing how to install the battery section. So we have now fixed the 4 arms and going now to install the battery part. Again. Okay, after that, the number 5, the assembly and debugging step number 5. Next step. Actually, we have prepared a short videos not to consume more time. Okay, so now let's go directly for the practical testing of the drones, how it can be. So also watching this short video, the drone flight training. Okay, so before flight, we need to check both the mechanical and electronic parts of the multi-motor drones to ensure the flight safety. Also, there is many steps we have to perform before the flight. The mechanical inspection first, as you can see here, check the propellers. If there is any damage, we have to change before the takeoff, and also correct the orientation. We have to ensure the motor rotate smoothly without any obstacles. We have to make sure that the frame is stable. Again, so two parts, it is important to make sure everything is okay before the takeoff. The mechanical inspection first and the electronic inspection. Again, this video to see how we can make sure before the takeoff of the drone. Before takeoff, we have to check that everything is finished and record the results, and also sign everything on the checklist, which is an important step before the takeoff. This is the second step before the takeoff. After powering the system, we first check the electronic speed controller, as I mentioned before, and this is actually a field drones. And also we use it for the training for the students. We check the electronic speed controller display. The remote controller also we have to check. We have to check that everything in the normal state. We need also to make sure the camera and the electronic device integrated with the drone, that they are working properly, and there is no abnormal heating. Also, we have to check the heat before the takeoff. We have also to check if the all indicator lights are correctly operated. Now going for the other step, apply the light again and perform. This is a short hover to confirm that stable flight. This is not the final takeoff. It is just to confirm stable flight. So we just make hover, not ascending, not descending. After that, going forward and backward, to make sure that the operation is stable.
Okay, very sorry for the trouble. It might seem that Dr. Mohamed has some issue with the technical. We might wait for a little bit, for about a minute. Maybe he will join with us to continue. We're very sorry for the improperly opening of this webinar. And also we in here we can already see Dr. Jhensen. How are you today?
Good afternoon, ma'am. I'm fine. How about you, ma'am?
I'm good. Thank you very much. Thank you for joining with us. You joined with us for the very first moment.
It's my pleasure, ma'am, to be here today.
Yes. Okay. Yes, we can wait for Dr. Mohamed. Please, for the other participants.
Ih, eh, lu tau
Ini
nggak sih ya,
abang
lebih
saya.
bagus ini loh kayaknya daripada name tag yang kita beli dari Himbio itu.
Yes, unfortunately, we are currently experiencing a technical issue with our speaker, Dr. Mohamed, uh, because of also the distance from China. Maybe there's some technical issue, and he wouldn't able to joining with us anytime soon. While we are sincerely appreciate and your patience and understanding. Now it's my great pleasure to welcoming our next guest speaker from City World College from Philippines, Dr. Jhensen Foronda. Please, all the participants, welcome to Dr. Jhensen. Are you ready to give a speech and lecture, Doctor? Yes, please welcome Dr. Jhensen Foronda, our distinguished academic and IT professional with extensive experience in information technology, artificial intelligence, software engineering, and higher education leadership. Today, he will share his expertise. Without further ado, ladies and gentlemen, please joining with me warmly welcoming Dr. Jhensen Foronda. Dr. Jhensen, the floor is yours.
Okay. Can you see my slide, ma'am?
Uh, we were, but
Not yet.
right
How about now?
now it's disappeared.
Uh,
Yes, it's visible for
it's
us.
visible now. Okay. So let's start. Okay. So, uh, am I audible, ba, ma'am?
Yes.
Wait lang. Okay. Uh, for a while. Um, okay. So, by the way, my name is Jhensen Foronda from WCC, World City Colleges, and from WCC Aeronautical and Technological College, North Manila branch. Okay, so welcome to our presentation on intelligent UAVs in energy response and disaster management. So today we are going to explore how unmanned aerial vehicles are completely rewriting the rules of emergency response during no, turning a traditional reactive approach into a proactive data-driven framework that saves uh, lives and secure critical assets. So when we talk about modern UAV operations, we are looking at a profound frontier. It is a paradigm shift in search and rescue and infrastructure resilience. By embedding artificial intelligence directly onto these airborne platforms, we shift from simply recording data to actively analyzing the data in midair, opening a brand new frontier of life saving technology. So let's look at the reality we face today. The rising frequency of extreme weather events demands faster, safer, and far more scalable response mechanism than traditional ground-based effort can be provided. So furthermore, our energy grids and power plants are highly vulnerable when disaster strikes. A rapid assessment of these electrical and energy systems is crucial to prevent catastrophic cascading failures. So, um, uh, why can traditional method uh, keep up? First, there is the golden hour obstacle. Survival rates drop by over 50% after the first 72 hours, and waiting for manned aircraft logistic waste precious minutes. So second, responder safely responder safely is heavily compromised by landslide, by flooding, or by hazardous environments. And finally, physical accessibility barriers like dense forest or urban rumble fields are virtually uh, impenetrable to standard emergency vehicle. So what makes UAVs intelligent? So um, so what makes a drone intelligent? It is the transition of artificial intelligence and edge computing. Modern UAVs don't just record footage to an SD card for later review. They possess onboard processing that allows them to see and react in real time. This includes immediate object detection to identify human forms or grid damage. Alongside, we have this autonomous path planning to navigate complex ruins without relying constant on human pilot. Next, deployment speed. In emergency situation, time is measured in lives. Traditional helicopters require extensive pre-flight checks and massive logistic coordination. In contrast,
Dr. Jhensen.
yes,
Oh, we're sorry for informing you that Dr. Mohamed has already joining us with us today.
okay,
You may continue your presentation after Dr. Jhensen. Dr.
okay,
Mohamed. We're very
Mohammed.
sorry. Yes. Dr. Mohamed, you may continue your presentation. There's some problem with the internet. Also because there's a lot of question has been asked from the participants that waited for Dr. Mohamed to answer. Dr. Mohamed, please sit with us for a moment for the participants. Thank you for your patience and understanding. Because of some problems, also with technical issue, Dr. Mohamed not being able to hear me.
Hello, sorry, we just faced the internet problem and interconnection problem. So we now can start again, but first we will share the presentation. So wait, please, few seconds.
Okay, we will wait for Dr. Mohamed to share his presentation with. Due to long distance, we're very sorry for the technical issue.
This is not working. Can you send it to me?
Okay, use my laptop. So use my desktop. And excuse me, and can you hear me, Lavita? Can you hear me?
Yes, we
Okay,
can hear
good.
you.
So just now, because of technical problem, the professor shut down, and now I will continue, and I will offer my laptop to professor. Moment, please, I will download the PPT to share.
Yes, thank you very much.
Goodness. Please.
We don't need this. So here that we are downloading the presentation again. Why we haven't used this format once? Sorry for what's happened. It was suddenly happened. So we are turning again now.
Yes, doctor, you may continue.
Okay, so
Okay, moment, please. This one finish? Not yet? No, it's not.
actually the file is almost 1 giga because it have many videos. So to download again from different source, it's taking time. So almost 1 or 2 minutes, we can start again.
If there's some problem with the internet, we can help you to share the PPT because we already downloaded.
Oh.
We have to
Almost
download.
Wait, it's okay. We're almost finished.
Yeah,
Just
yeah.
1 minute.
Okay, thank you.
This battery is okay. That's why I asked you to make a space for this. Videos.
Okay. So
hello. We already installed everything and going to start again.
Yes, we already see the presentation.
We are really apologize for what's happened, and now the connections is fixed. So let's again start with this slide to show you, or we can start from the previous slide. Look at it, and we can continue again after a while. Here we check the electronic speed controller and the remote controller that everything is fixed. Okay. Okay, so this is the up and down and hover process. Next, we will check the forward and backward, left and right, and try to make the yaw movements. Check the flight altitude, to the control response, the flight modules. That everything is ready for the takeoff. Hello?
Yes, doctor?
So you still listen to me, right?
Yes, we can hear you.
Okay, this is also another step for training and to make sure the operation before takeoff. This now you can see forward and backward, left and right, and also the yaw movement. Okay, let's check for the Okay, now we will continue with the detailed application for the drones, which I think it will be more interested for many people. Especially for the electrical engineering. The first application we will discuss about the drone inspection, how we can utilize drones for inspection, especially for the electrical engineering applications. Actually, many years ago, we was depending on the manual climbing, and I mean, all of the applications was manual, which have the disadvantages of the slow, costly, and dangerous. But nowadays, we replaced all of the process, or most of the process, using drones, which are carrying the high definition cameras and also the infrared beams, and also the light detection and ranging technologies. Depending on the UVA or the drones nowadays, provided the safety, the coverage area, it is expanded, and also the predictive power. So this is one of the most important application we usually depends on the drones. It is now more safe to keep the technician on the ground away from the especially high voltage risk. And also drones can access a remote mountains area, which is very difficult to use or to climb using the human efforts. actually depends on the drones. We can prevent the failure because of these usually happen. Now we can ensure the reliable power system and make the diagnosis using the UVAs or drones. As my major is electrical engineering, so usually we depend on the drones for the inspection for the high voltage towers, for the insulators, for the cables. And someone may ask, okay, after taking the pictures, what we can do? Actually, we have the high definition cameras first, the infrared. We have the leader. We call it LIDAR or LIDAR, the light detection and ranging technology, which can, after taking the picture, we can analyze and know what is the problem exactly in the towers or the power line, and also for the insulators. Okay, going for the another application, which is the architectural, using for agriculture drones. First, to try to find here the weight we can carry on the drones, more than 200 kilogram. This machine actually completely replaced the manual sparing, and also have the three fold advantages. First is the precision, saving the time, and also saving the humanity. And also we can work in a large space to save the time and save the human ability. So this is also another common application for the drones. Actually, this also will serve for the future of the sustainable farming. Look at the drones, how to act for the agriculture irrigation. And of course, saving the cost and low environmental impact, because of at the beginning or previous, we was depending on the agriculture machines, which usually consume fuel. After the finishing the water, of course, it can be replaced again, and everything should be controlled. I mean, the weight and also the speed, the area of the irrigation, everything must be controlled in advance, and this is also the battery. Another application which also will be interested is the heavy lift drone. I'm sorry for this is in Chinese, but I can translate or what is the application exactly. Now we depend on the drones to lift and also deliver the load of more than 200 kilograms. I think no need for the sound. I think it is very difficult to understand the Chinese. So looking at the third application, which is the heavy lift drones. This technology is actually the most challenging environmental technology because we depend on the drones for lifting the weight, and also must be calculated to avoid any risk. The core advantage of this application is the accessibility, and also the safety, and finally the cost and the sustainability. Compared to the helicopters, drones also cheaper to operate and also have a smaller emission. I mean, the carbon footprint, and also require no landing strips. Of course, it will be helpful for the emergency situations. Also, I mean, you can employ it for different application, especially now, as you can see, everything is controlled and deliverable from a place to another place, and also can be helpful for complex situations. Another application is the drones using for surveying and mapping. It is also helpful for people who are working in engineering in general, to replace the traditional and incentive ground surveys, and also provide a high precision drones with, actually it is integrated with another technology like the leader I took it about, and also have multi sensors. So drones for mapping integrated with another technologies. The main advantage here, as I mentioned before, the high efficiency and the precision is compared to other devices. Of course, the saving time, and also saving cost, and the total safety, as we eliminate the need of the teamwork to and also avoid the dangerous from many process. So actually, this technology now provide a faster and safer and more accurate than the manual methods, with also different kind of, this is the last few seconds showing how the manual or different kind of drones can provide. Now we are going to talk about the coordinated development in the regional development. So we are now focusing on the Fujian. As I mentioned before, Fujian province is one of the biggest provinces in China. To achieve the balance, high quality across Fujian, usually using the geography on two pillars. One is the mountain sea synergy, and the other one is the urban rural integration. So Fujian connect the coastal industrial hubs with the resource-rich island mountain regions. This actually facilitates the industrial transfer and the development gaps, also connecting the urban and rural integration by synchronizing spatial railing and infrastructure, to bridging the service divided into education and healthcare. So the result of this is actually sustainable model that can integrate the economic process with the ecological protection, and also province overall competence. Talking about the future of the UVA or the drones. So the drones market now experiences an explosive progress. Actually, the global commercial drone market now is set to be double by 2033. As you can see, the progress now of the world are increasing for China, reaching over than 52 billion RMBs for this technology. Actually, this growth is fueled by several key technologies. The first one is legalization first, because as we mentioned before, it is not haphazard to use the drones. We should follow and obey the legalization from the, for the air flights. Also, the second one is depends on the AI-powered autonomous. And the third one is the battery technology, which is finally overcoming the range of 40% increase in the flight time. So there is now three challenges. The first one is the legalization. Second one is the integration of the high technologies. And the third one is the battery problem, which nowadays we are trying to enhance the efficiency and the time for the flight. And lastly, the 5G connectivity, which is providing the necessary system for the connecting it to the sky. Finally, let's talk about the future of the city travel. I think this is not expected, but there is some countries already applied for the mobility, or we call it urban air mobility, or UAM. We are now witness to $1 trillion vision centered for the electric aircraft that take off and land vertically. So focusing on this. So take off and land vertically. And this is actually entirely new ecosystem and spanning aircraft design and smart system, and also autonomous traffic management. So we need to do that. I mean, this is the plan for the future. We are looking for more than $1.5 trillion by 2040, with over than 10 billion already dividing global development. We are intended to have the commercial operation of launching more now in the key cities, not everywhere, with a global of mainstream integration by the mid of 2030. The challenge now is to get to solve the triple threat. The first triple threat, which the first one is the battery density. Usually, this kind of drones face the battery density problem. Number two is securing the public trust. How to secure the drones, because it is sometimes used for the strategic process. And finally, finalizing the global flight regulations. So three challenges now. The first one is the battery density. The second one is the security, how to secure, and we already discussed how to secure the drones by having the ID, having the certificate, and also follow the regulations. Finally, the global flight regulations. Now, let's talk about the drones for delivery. I think most of us have, so the delivery depends on the drones, which has already shifted from the experimental concept to multi-billion dollar industry. We are now looking at the market expansion from 1.5 billion to 7 billion by 2031. The market scale, as I mentioned before, the number of the active delivery drones is arrived now to 30,000 to over more than 300,000 by 2030. The key players here is the industry leaders like we have, we are well known for us, the Zipline or Amazon, are scaling the models from the critical medical logistics to high volume retail. And also the challenge now is the integration, not only the innovation. For the conclusion and appendix, actually, the future of drone, it is not just only about the hardware. We already have the advanced platform for the hardware. It is about the building a safe, reliable, and intelligent and fully integrated ecosystems that as I mentioned a few minutes ago, it is not only drones, it is integration with another technologies. So driven by AI, artificial intelligence, and also transformation application like the UAM, the Urban Air Mobility, and the drone delivery, this system actually will redefine the economy and daily life. To conclude, the sky is no longer just a limit, it is our new frontier. As you can see, if you have the presentation, this appendix provides the quick reference to the core data points discussed before. Especially, we focused on Fuzhou, which our living area now, which is targeting now more than 400 enterprises for the drones factory, and also benefits in many applications like 60% cost reduction and the power inspection, and more than 90% efficiency increase in the medical transport. Actually, these numbers underscore the significant impact and the potential of the drone industry in the global China and on the provincial level Fujian, and also on the city level Fuzhou. This was the last slide, and I'm really thank you for your attention. And also, if you have some questions now, we are ready to answer some question for a few minutes, because we already lost some minutes during the interruptions happen. So you still listen to me? Oh. Okay, actually, these reports, I think, cover almost the questions you need. So kindly, if you have any question, you can write it to me. And also you can follow the presentation for the question. And this is the annual report for 2025. We can have the annual report for 2026 after few months. And again, I would like to thank you. And sorry for the interruption happened today, and hopefully to meet you again in the next webinar. Thanks, and see you soon.
Okay,
Bye-bye.
thank you. Okay, thank you
Bye-bye.
very much, Dr. Mohamed.
Thank
Thank
you.
you.
Bye-bye. Bye-bye.
Okay, thank you very much for the interesting and excellent presentation, and also
Okay,
valuable
appreciate it.
insight. Thank you very much,
Thank you very
Doctor.
much. Thank you. Thank you. Bye-bye.
Yes. Have a good day. Okay, for the question that has been asked, you may contact Dr. Mohamed by email if you have anything in mind. And the question for today hasn't been able to be answered because Dr. Mohamed has another occasion schedule. Okay, shall now we proceed to our second distinguished speaker from World City College, City World College Philippines, Dr. Jhensen Foronda, Dr. Jhensen Foronda, may you please open your cam? Yes. Dr. Jhensen Foronda, Lecturer, Faculty of Information Technology, City World College. He will present his topic entitled with our theme today. Are you ready for giving presentation, Doctor?
Yes, ma'am. Yes, ma'am.
Yes. The floor is yours, Dr. Jhensen.
Okay. Uh, okay. Am I audible, ma'am?
Yes, you're audible.
Okay. So again, so my name is Jhensen Foronda from WCC Aeronautical and Technological College, North Manila. So for my presentation, I would like to talk about intelligent UAVs in energy response and disaster management. So today we are going to explore how unmanned aerial vehicles are completely rewriting the rules of emergency response, turning a traditional reactive approach into proactive data-driven framework that saves lives and secure critical assets. Okay, so when we talk about modern UAV operations, we are looking at a profound frontier. It is a paradigm shift in search and rescue and infrastructure resilience. By embedding artificial intelligence directly onto these airborne platforms, we shift from simply recording data to actively analyzing the data in midair. So opening a brand new frontier of life-saving technology. Okay. For global crisis and energy infrastructure, so let's look at the reality we face today. The rising frequency of extreme weather events demands faster, safer, and far more scalable response mechanism than traditional ground-based efforts can ever provide. Furthermore, our energy grids and power plants are highly vulnerable. When a disaster strikes, a rapid assessment of these electrical and energy systems is crucial to prevent catastrophic cascading failures. So, what are the limitations of traditional uh, um, methods? So, first, there's the golden hour obstacle. What do we mean by that? Survival rates drop by over 50% after the first 72 hours and waiting for manned aircraft logistic. So we waste precious time, okay, in minutes or in seconds, okay, in surviving the critical events, in critical events. Second, responder safety is heavily compromised by landslide, by flooding, or hazardous environments. And finally, physical accessibility barriers like dense forest or urban rumble and virtually impenetrable by standard emergency vehicles. So for the next slide, let's talk about what makes UAVs intelligent. So what is all about? So it is the transition of artificial intelligence and edge computing that makes UAVs intelligent. So modern UAVs don't just record footage to an SD card for later review. They possess now onboard processing that allows them to see and react in real time. This includes immediate object detection to identify human forms or grid damage. Alongside, we have this autonomous path planning to navigate complex ruins without relying constantly on human pilot. So next, deployment speed and the second count. Every second counts. In emergency situation, time is measured in lives. Traditional helicopters require extensive pre-flight checks and massive logistical coordination. So in contrast, enterprise UAVs can be airborne in less than 15 seconds. Trials show that drone-assisted teams locate victims with an average of 3 minutes faster in immediate search zones. Every minute determines life or death. Next, um, what is hypervisibility? Hypervisibility, this brings us to our core operating capabilities. Starting with hypervisibility by utilizing thermal and multispectral sensors. These intelligent drones can detect human body heat signatures. So, through dense smoke, thick forest, so it is capable to identify the human body heat, even in pitch black darkness. This eye in the sky provides a 360 thermal map of the disaster zone, finding living survivors where human eyes see nothing but debris. Rule number 3, autonomous search. Next, we will talk about what is autonomous search. We use advanced AI or artificial intelligence algorithm to analyze high-resolution feeds and instantly tag objects of interest, such as bright color jacket or localized heat bloom. This allows operators to focus purely on the rescue strategy rather than straining to entire square kilometer in under 10 minutes. Okay, so let's talk about multi-UAVs swarms. So the question is, what if the area is too massive for a single drone? That's where multi-UAV swarms come into play. Multiple drones can work together autonomously to map massive areas in parallel. They possess built-in redundancy, so if one unit fails or drops out, the remaining swarm automatically redistributes the search area, ensuring 100% saturations and recovery of the victims. And also, it also cover incredibly hostile terrains, so even in dark, pitch black environment. Next, rule number 5 for connection hub. When disaster strike, communication infrastructure is often the first thing to go. Intelligent UAVs can act as flying cell towers, rapidly establishing airborne mesh networks to restore connectivity in blackout zones. By streaming 4K footage from remote areas to global command centers via satellite, of course, like Starlink, and using onboard speakers to broadcast instructions to survivors. They bridge the gap between the victims and rescuers. When it comes to energy focus, shifting our focus to energy infrastructure, like the one said the speaker a while ago. These drones are game changers for post-storms grid assessment. So UAVs can fly centimeters away from high voltage lines, identifying hairline fractures, damaged insulators, or vegetation corrosion, all without shutting down the grid. The paradigm change here is clear. Inspectors stay safe on the ground, and tower climb times are slashed by 85%. Next. For the renewable resilience, renewable energy assets needs rapid recovery. Okay? Following severe hailstorm or hurricanes, drones equipped with LIDAR and thermal imagery and can scan thousands of solar panels or inspect massive 80 meters wind turbine blades. This process is 10 times faster than manual inspection, allowing utility providers to safety get clean energy back on the line. So for the next slide, we have the SAR, the SAR revolution in action. So let's look at real world application. Okay, especially in search and rescue revolution. In raging floodwaters, where rescue boats cannot safety venue, let's say for example, heavily lift UAVs serve as a precision lifelines. They can fly directly onto stranded victims and drop self-inflating vest. And also, uh, it can also bring communication radios effectively by holding and securing the victim positions until full extraction team can execute safe plan. So next, during wildfire event, in wildfire scenarios, visibility is practically zero. So UAVs give fire commanders a vital strategic edge by providing real-time tracking of hotspots right to thick smoke that completely blinds traditional helicopters. So long endurance drones can monitor the fire uh, perimeter as long as 24/7. So command centers can issue preemptive accurate evacuation order well ahead of time. So that's the power of UAVs nowadays. Next, in terrain modeling, another critical application is aerial photogrammetry and 3D terrain modeling. So by converting thousands of high resolutions aerial photos into precise 3D digital twins, okay, we can accurately identify safe routes for ground teams and assess the structural integrity of compromised bridges. And also, we can also rapidly calculate the exact volume of debris that needs to be cleared by using drones. So, urban search and rescue operations and ruin navigations. So, in Inder Hazard, we deploy rubble specialists. These are miniature drones equipped with protective prop guards designed to fly directly inside collapsed structure when human search team or K9 cannot safely go. Utilizing localized LIDAR, they map out the dark interior architecture, ensuring zero human risk during the crucial initial structural proving phase. For long range operations, we also uh, need to cover expansive areas like coastal borders or deep mountain ranges. We leverage the vertical takeoff and landing fixed wings drones like this one in the image. They combined the vertical takeoff flexibility of a helicopter with the aerodynamic efficiency of airplane. With over 4 hours of flight time and a range exceeding 100 miles per mission, they can change the scale of what a single deployment can achieve. For data analytics and raw to actionable, the advantages become undeniable by using UAVs. When you look at the raw data matrix, let's compare traditional methods to intelligent UAVs. The deployment time drops from up to 1 hour to under 2 minutes, a 95% reduction. Area coverage expands exponentially. Data accuracy jumps to sub 3 centimeter fidelity 3D models. And mission safely goes from highly hazardous to absolute safety with zero human risk. That's the data analytics of UAVs. Next, the economic impact. So beyond saving lives, there's a clear economic justification. According to the energy sector economic review, implementing this automated intelligent inspection system drastically minimizes downtime, protects billions of dollars in utility infrastructure, and eliminate the staggering liabilities associated with traditional manual field operations based on energy sector economic review held on 2024. Next, what are the technical challenges we faced in UAVs? Of course, we must look at the current bottlenecks. Okay, standard battery limits up to 30 to 40 minutes remain constrained, and severe weather can still ground lightweight systems. Okay, so true IP-related weatherproof is rapidly improving. Furthermore, navigation beyond visual line of sights, flying presence, regulator, and hurdles that require unified, unmanned traffic management architecture to say blend with human um, manned aviation. So that's the technical challenges in UAVs. Next, the road ahead. What is the future tech? So looking forward, the future is incredibly promising. Next generation hydrogen fuel cells are entering the market, promising extended flight times up to 8 hours. We are also looking at drone in a box stations that automatically deploy systems the exact second an earthquake or grid fault is registered. The ultimate vision is a fully autonomous permanent global emergency response network. So for the conclusions, to close this meeting, I will leave you with this thought from Global Disaster Response Coordinator. In search and rescue, the UAV is not just a gadget. It is the difference between a recovery mission and rescue mission. So again, on behalf of WCC, thank you for exploring the future of emergency response with us. Thank you.
Okay, thank you very much for the insightful presentation and the valuable insight. Now we move to the Q&A session. We already see a lot of questions in the chat box right now. We move to the first question that is from Jaja. The question is, how do UAVs locate survivors in areas where GPS signals are weak or unavailable? Dr. Jensen?
Okay, as I mentioned earlier, as I mentioned earlier, nowadays we use artificial intelligence, including the machine learnings and data annotations as well. So I discussed already the LIDAR and the infrared sensors a while ago, which is capable of monitoring even in dark pitch environment. So those capabilities came from the artificial intelligence which we are trained to identify specific objects. So by using the AI technology incorporated to the drones or the UAVs, we are now capable of citing or managing uh, even the small details for specific data we are searching. So if we are searching, let's say for example, a color jacket, for instance, the machine language or the AI can definitely identify by using data annotation pipeline, okay, so or in technology. Nowadays, AI is everywhere. So AI can modify, AI can learn itself, and you can prompt AI whatever you want to search. And of course, we have also the sensors. We can integrate all the sensors in our UAVs and to formulate or to create more extensive drones in the future.
Okay, thank you for the answer, Doctor. May the answer satisfy Jaja question. Okay, the next one is there's from Patricia. Good afternoon, sir. Intelligent UAVs are increasingly being used to inspect renewable such as solar farms and wind turbines. In your opinion, what technological advancements more efficient, accurate, and cost-effective?
And renewable energy like clean solar system. Based on the presentation a while ago by Dr. Mohamed, he stated that UAV is using nowadays for some reason, especially in economic crisis. So he stated a while ago also save enough of fuel compare when you use a helicopter or a big mechanical system, like such as aircrafts or something like that. effective in doing that. Again, during my slide, so I discussed regarding what are the future will bring in terms of modifying and enhancing our UAVs. Included in our presentation is by using um, hydrogen fuel, which is and making the battery life or battery of the drone much high, up to 8 hours. For constraints, we have only 4 hours limited battery life in our drones as of now. But in the future, or even if we have this kind of the technology, we continue to expand our modification in terms of UAVs. So, what are the other questions? Uh, what opportunities exist for collaborative research between the Philippines and Indonesian in this field? Okay. Um, what are the collaboration? For sure, we need to collaborate in research opportunities. The Philippines and Indonesia in the fields of technology management and IT education, I think it will become robust. So primarily um, driven by bilateral academic partnership, okay, regional ASEAN initiatives, or shared interest in digital transformation. So, if you are more focused on UAVs, because we are in um, aeronautical school right now in WCC, I'm in aeronautical and technological school. So we can collaborate regarding those kinds of technology like UAVs, if you want, or if the Indonesian country wants. So I think bilateral partnership in academic, this is a strong precedent to direct university to university cooperation. So I think uh, that's the main solution in regards to the collaborative research between Philippines and Indonesia. So next question, wala na yan.
Yeah. Thank you very
Alright.
much for your answer.
Thank you.
There is a Jaja in here said that what if Dr. Jhensen able to help answer my question earlier because Dr. Mohamed didn't answer. Would you willing to answer that, Doctor?
Uh, what is the question, ma'am, for
Yes.
specifically?
Okay, let me see. If I accidentally overtighten something or mess up with the alignment while building it, will its smart software freak out and give me a fake error code? I think
Uh, wait lang.
um
I'm searching for the question.
yes.
So I'm confused for the.
Yeah, it
So you
says
mean
that. Mhm.
if you have this kind of error, um, uh, it would be fatal for the drone or the UAV or UAVs, something like that. So it sounds like you are discussing about critical failure, right? Or the critical system error, like something like that. So When a fatal error occurs in a flight software, because we are in aeronautical school, um, let's say, for example, hardware communication failure, or the collaboration of IMU from the system, or loss of communication, or severe memory buffering, like something like that. Okay, so of course, definitely the UAV can indeed suffer. Okay, leading a complete loss of control, or immediately power down the entire device, or the UAV. Okay. For sure, for this error, we can have the result of loss of altitude estimation. Number one, in aerial in aerial UAVs. Of course, we have this kind of. I think it will. It also discussed a while ago by Dr. Mohamed regarding ESC, or communication timeouts. Definitely, so we will be having the problem in communication. And I think for safety reason, we need to to determine the holistic environment of the system. Like for example, Dr. Muhammad stated, like for example, the CPU load spikes, indicating the processor is overwhelmed and unable to execute the flight loops. So what else? What kind of errors pa? So if you are dealing with specific error message, or recurring crash issues in UAVs, so you must think, or you must read the manual first, or you must research. In information technology, we have four pillars. You need to understand the design, of course, create the prototype by conceptualizing or actual construction of the conceptualized design. And after the development, you need to test and improve the design, or the implementation, or the development of the project. And after that, you need to evaluate the whole system. So to avoid those errors, you need to research. That is the only way. Okay, you need to research, gather data, and make an analysis for the gathered data, to be able to be sure that everything will work fine.
Okay, thank you very much for your answer. I hope Jaja is satisfied with the answer. And it seems that's all the question, and it has been answered, all of them. So thank you very much, Dr. Jensen, once more for the thoughtful answer and
Thank you,
sincere
Doc Cheetah.
appreciation for your. Yes, thank you very much. And also thank you
Thank you,
for the
thank you
participants
very
for
much
us.
for inviting me.
Yes, thank you very much. See you soon on the next collaboration, Doctor. Okay.
To see you soon, Dr. Cheetah.
Yes, thank you. Okay, thank you very much. Now our final speakers today comes to STEKOM University. Please welcome Dr. Migunani. Dr. Migunani, yes, welcome.
Thanks.
And Dr. Migunani is a head of information system department of STEKOM University. He will deliver the presentation of today's theme. And ladies and gentlemen, all the participants, please welcome Dr. Migunani. The floor is yours, Doctor.
Okay, thank you, Ms. Gita. Good afternoon, everyone. Today, I will present a transformative framework in inventory management and warehouse volumetric analysis through the integration of indoor UAVs or drone with a warehouse management system. This topic is synthesizes three cutting-edge research study that collectively redefine how we conduct stock taking and inventory audit in the Industry 5.0 era. Today, presentation will follow a systematic flow. We will begin by understanding why inventory management is crucial, then identifying the weaknesses of a traditional approach. Next, we will discuss three technological breakthroughs that serve as the foundation. The core of the presentation is the four passes framework that integrate these three technology. We will also look at implementation result and how this framework can be scaled for various warehouse size in the inventory. In today's fast-moving modern supply chains, inventory accuracy is not optional. It is imperative. Every physical product must be precisely represented in the company digital system. When discrepancies arise, the impact of massive order fail to be fulfilled, dead stock accumulates, and working capital become inefficiently tied up. This is why the stock taking process becomes so critical. Traditional approaches have inherent and fundamental weaknesses. First, the process is extremely labor intensive and time-consuming talking days and relies on human accuracy that susceptible to fatigue and errors. Second, and most damaging, comprehensive audit force management to halt warehouse operations. During stock taking, no goods enter or leave. This represents a massive opportunity cost for the company. This challenge become even more complex with evolution of modern warehouse architecture to maximize space utilization. Logistic facilities now use high bay racking system. Scanning barcode on these towering racks forces staff to use heavy equipment like scissor lifts. This not only slow down the process, but introduce significant OHES risks, falling from heights, equipment accident in narrow islands. This is the gap that UF technology aims to fill. To break through this impasse, indoor UFs emerged as a revolutionary solution. Indoor drone acts as more than just flying vehicle. They function as a dynamic Internet of Things nodes moving through three-dimensional space. With the ability to maneuver in a row isolates and reach the highest rack quickly, UF transformed the stock-taking paradigm from a reactive agenda that halts operation into a proactive, continuous, and most importantly, safe data monitoring stream in the inventory. The development of indoor UF technology did not happen through a single invention, but through a series of complementary technical resolutions. Let's look at three major milestones. First, Choi and Lee solved the navigation problem in GPS unit environment using SLAM algorithm. Second, Betty and Kollega built a communication bridge to integrate UF data into VMS. And third, Wang and Yu optimize computing with edge computing together. They form a complete foundation. The most fundamental challenge is How can a drone fly autonomously inside a building without GPS signal? Choi and Lee answer this by implementing depth camera and a lightweight LiDAR sensor running SLAM algorithm. The drone simultaneously built a 3D map of the warehouse and calculate its own position within the map. And the result, a drone can maneuver in isolates with less than 2 meters between racks without collision. This is the foundation that enables all subsequent technology. An automatically, an autonomously flying drone provides no business value if its data remain isolated, creating data silos. Betty and team address this by building a communication architecture that bridge UAV with VMS. Every time the drone scans a barcode, the data is instantly transmitted and matched against the enterprise database in real time. This transforms the drone from a mere flying camera into a living, breathing database audit tool. The final challenge is a swap. Swap is size, weight, and power. Continuously streaming a high-resolution video would burden the network, while carrying a large computer on the drone would drain the battery in minutes. Wang and Hu solved this with edge computing, processing down directly on the drone's microcontroller. Barcode images are extracted into lightweight SKO text, just a few kilobytes. This enables the use of inexpensive, efficient micro UAV with accuracy above 95%, even in challenging lighting conditions. Now we reach the core of the framework. The synthesis of the three research studies yield for past architecture that are sequential and interdependent. Starting with pass 1, spatial mobility, where the drone moves and maps the environment. Pass 2, edge computing for data extraction. Pass 3, IoT middleware for data transmission. And pass 4 is WMS reconciliation that produce the managerial dashboard. Let's examine each puzzle in detail. The puzzle 1 is the physical foundation. Here, the drone lands from its docking station and takes flight. Using LiDAR sensor and depth camera, the drone runs SLAM algorithm to simultaneously build 3D maps of the environment and calculate its own position. The obstacle avoidance system ensures the drone safely navigates around moving forklift and static pillars. The output of this pass is a precise coordinate and accurate warehouse map. Without this, the subsequent passes are impossible. Sorry. Once stabilizing positioning is achieved, the drone does not record raw video, which would burden the network. Instead, it activates the local intelligence system on its microcontroller. The camera captures images of product label on the top of rack. Algorithm perform photogrammetric correction to flatten image. taken from oblique angles. Then computer vision extract the barcode. Here, the fascinating part, megabyte-size images are immediately converted into SKU, text that just a few kilobytes. This is the magic of edge computing. Heavy data is processed locally, while only the lightweight results are sent to the server. Fuzhou 3 provides the physically data that has been extracted so it can speak the language of the enterprise database. The SKU data from Fuzhou 2 is combined with rect coordinates from Fuzhou 1 and timestamp, then wrapped in JSON format. This language package is transmitted via MQTT protocol, specifically designed for efficient IoT communication. The data enter the IoT middleware, which acts as a filter and security gateway, ensuring only valid data is forwarded to the VMS. This is the bridge that transforms the drone into an integral part of the company IT infrastructure. The final puzzle occurs entirely within the information system realm. Once the VMS receives the data package, it matches the drone's physical finding against the digital manifest. If a discrepancy exists, for example, the drone scans an SKU at rec A, but records say it should be at rec B. The system immediately triggers a real-time alert. Moreover, the combination of 3D mapping and then an item identification enable the VMS to accurately calculate warehouse fill ratios. The end result, comprehensive stock taking without halting operation, with 100% accurate inventory visibility. This framework is not just conceptual. Field implementation proves three major achievements. First, drone can maneuver in islands with less than 2 meters between racks without collision, drastically eliminating OHS risks. And second, the photogrammetry system achieves a barcode detecting accuracy above 95% even in challenging lighting conditions. And third, and most financially impactful, stock taking time shrink from day to hours. Audit costs and downtime are dramatically reduced. One of the key strengths of the framework is scalability for small SME warehouse. A single micro UAV with ASP32 cam operating after hours insufficient. For a regional distribution center, 3 until 5 drones with industrial grade hardware and managed network are needed. And for mega fulfillment center like those global e-commerce company, we are talking about a dozen of drone with swarm intelligence, private 5G network, and predictive AI operating at 24/7. The framework grow with your business needs. To aid understanding, let's look at the data flow visually, starting with the drone talking off the mapping the warehouse, then moving to edge computing for the data extraction, followed by a transmission through IoT middleware, and ending at a VMS which produce the managerial dashboard. 4 passes, one data stream that transform physically inventory into a real-time business insight. This is the closed-loop automation that represent the ultimate goal of warehouse digital transformation. In conclusion, there are 5 key points I want to emphasize. First, that is synergy is key. No single technology stand alone. Navigation, integration, and edge computing complement each other. Second, we shift from reactive audit to proactive continuous monitoring. Third, zero downtime become a reality. Stock taking without halting operation. And four is workplace safely improve dramatically. And fifth, this framework is scalable for business of all size. Future research challenges based on the synthesis are no longer about proof of concept. The focus shifts to battery power management, swarm drone coordination, and algorithm scalability at mega distribution center. Cybersecurity also become a concern. How to ensure drone data is not compromised. But one thing is certain, the future of inventory is no longer on paper or spreadsheet screen, but in the air, monitored by drones flying intelligently among warehouse rack. Then, thank you for your attention. I am ready to question.
Thank you very much, Dr. Migunani, for sharing your remarkable expertise and your research experience with us. Now we have arrived to the next session, and that is Q&A. For all the participants, if you have any question, please chat to the chat box in the Zoom. But right now we have already some question has been asked from all the participants. The first one is from Yusuf. The question is, Dr. Migunani, in your opinion, what is the biggest advantage of integrating indoor UAVs with warehouse management system compared to conventional inventory management methods?
Okay. Thank you for your question, Mr. Yusuf. Okay, integrating UF fundamentally changed the nature of the data pipeline in several critical ways. The first one is UAV as roving IoT nodes. Instead of relying on a stationary sensor or human-operated scanner, UAV acts as an autonomous mobile IoT gateway equipped with computer vision, LiDAR, and RFID arrays. They don't just ping a barcode, they map the physical space. This bridges the physical-digital gap, feeding high fidelity and multimodal data directly into the VMS architecture. And the second one is enabling advanced AI and algorithm optimization. Machine learning models are only as good as the data fit into them. You cannot run effective predictive analytics, automated dynamic slotting, or ensemble forecasting model on stale inventory data because UAV can perform autonomous cycle count of hours or continuously in the background. They provide the real-time, clean data set required for VMS to leverage advanced AI, moving the system from reactive record keeping to proactive optimization. And the third one is volumetric and spatial reality. Conventional methods usually provide a binary status. An item is either scanned in a location or it is not. You have equipped with optical sensor can assess how a pallet is sitting, detect physical damage, and calculate volumetric space utilization on top tier rack that are historically dangerous or time consuming for human worker to audit. And the fourth one is eradicating the phantom inventory problem. Human error in conventional scanning often leads to phantom inventory, where the VMS thinks a product is available, but is physically missing or misplaced. The high-frequency auditing capability of UAFs align the VMS database with physically reality almost perfectly, preventing the cascading failures that happen when production or fulfillment relies on incorrect stock level. Ultimately, it is just about moving faster. It's about creating a true real-time digital twin of the warehouse. Are you looking at this integration more from perspective of the physical hardware and sensor framework on the UAVs, or from the how the WMS backend algorithm process and learn from the influx of data? Okay, this is my answer for your question. Thank you.
Okay, thank you very much for the answer, Doctor. The next one is from Jaja. How long does it typically take to implement an indoor UAV and WMS integrated system in an existing warehouse?
Okay. Thank you. How does AI improve object recognition accuracy in a complex warehouse environment? Or, sorry, Mr. Jaja. How long does it typically take to implement an indoor UAV and VMS integrated system in an existing warehouse? Okay, thank you for your questions. If implementing a brand new VMS alongside your system, we are looking at 4 to 12-month projects. The bottleneck here isn't the drones. It is the standard deployment cycle of VMS, cleaning legacy data, migrating database, and configuring workflows. However, you are integrating a UAV system into a warehouse that already has a modern, functioning VMS. The timeline shrink dramatically to 2 to 8 weeks, and modern indoor drone provide like Gather AI or 50 use a cloud-based platform and IPA, application program interface hooks, that bypass the need for heavy and premise it infrastructure. The hidden bottleneck, even with existing VMS, a few real-world issues can drag this timeline out by several weeks. The first one, barcode and rack hygienes. Drone really on a line of sight. If we current workforce habitually place pallets with a barcode facing backward, or if you rack label are peeling and non-standardized, you will spend weeks physically reorganizing the warehouse before the drone can be useful. And VMS architecture. A cloud-based system like Manhattan Active or SAP IBM in the cloud can connect to a drone provider's IPA in a matter of days. If we are using a heavily customized legacy on a premise VMS, Building the middleware to allow the two systems to communicate will delay deployment. And the three is network infrastructure. While some drone process data on the edge and only upload when docked, others require a constant connection. If your warehouse has major Wi-Fi dead zones, you might have to upgrade your network infrastructure before flight can begin. Okay, this is my answer for Jaja question.
Okay,
Thank you.
thank you very much, Dr. Migun. Next question is from Ray. How does AI improve object recognition accuracy in complex warehouse environment?
Okay, thank you for your question. Artificial intelligence improve object recognition in complex warehouse environment by moving beyond simple rule-based scanning to sophisticated deep learning-based perception system. In a setting where traditional sensor like a barcode scanner or RFID fail due to poor lighting, occlusion, or damage label, AI provides the vision to interpret the skin contextually. How AI overcome complex warehouse challenges? AI system typically utilizing deep learning like CNN model or algorithm and computer vision tackle the inherent variability of a warehouse through several architectural advantage. The first one, handling occlusion and clutter. Conventional systems struggle when an item is partially hidden or buried in a clutter bin. AI model, particularly those using instant segmentation, can recognize an object even when only a portion of it is visible. By training on vast dataset of partially obscure item, the model infers the full shape of the product, allowing it to identify item than a human or a standard laser scanner would miss. The second one is adaptation to lighting and environmental variance. Warehouse lighting is rarely uniform. It changes throughout the day based on sunlight, shadow, and high intensively overhead fixture. AI models are trained using data augmentation, a process where the training images are programmatically altered to include different lighting conditions, rotation, and maybe blur image. This makes the model robust to the noisy visual environment of the real warehouse. And the third one is a future-based recognition, vs tech dependency. While traditional system really on a 1D, one dimension, or 2D barcode, AI vision system recognize an object by its unique visual feature, like shapes, texture, color, and packaging design. If a label is torn or missing, the AI can often still identify the product by the characteristic appearance, ensuring that the VMS retain accurate stock level despite physical damage to the item identification media. And the next is semantic understanding. That is a contextual awareness. Advanced system use semantic segmentation to understand not just what an object is, but where it is, how it relates to its environment. For example, the system can distinguish between a pallet that is correctly placed in a rack versus One that is drifting. Drifting is partially protruding into an aisle, which prevent collision for autonomous mobile robot like AMRs and human-operated forklift. And the next is real-time edge processing. By deploying AI model and edge computing hardware, GPU, graphical processing unit, located directly in the camera or a local server. This system performs inference in milliseconds. This real-time processing allows for immediate feedback, such as alerting a worker if they have picked that wrong item before they move to the next bin. What is a K technology? Technological technique used to be better understand how this system process the complex noise of a warehouse. It is helpful to look at a specific visual recognition layer that is used object detection, identifying the presence of and coordinate of specific item, and instant segmentation, mapping exactly which pixel belong to a specific object, allowing the system to distinguish between two identical boxes sitting next to each other, and use OCR. OCR is optical character recognition. There's optical character recognition reading text directly from a label or containers to cross-reference with the VMS, even when the label is skewed or printed at an unusual angle. By combining this method, AI transform a static camera fit into a dynamic aware system, then continuously update the digital twin of your warehouse and effectively eliminating the common discrepancies that occur when manual scanning is fails. Okay, this is my answer. Thank you.
Okay, thank you, Doctor. We move to the next question from Patricia. I would like to ask, how does integration of indoor UAVs with warehouse management system improve the accuracy of efficiency of volumetric analysis compared to traditional inventory management methods?
Okay, thank you for the questions. Integrating indoor UF with a VMS elevates volumetric analysis from an occasional error-prone manual estimation to continuous high-precision automated workflow. In conventional inventory management, calculating volume, how much of a bin or rack space is actually filled, is usually done by periodic human audit or based on a theoretical cubed dimension stored in the VMS, which rarely account for real-world irregularities like overhanging pallet or shifting loads. The integration shifts this dynamic through three primary advancements. The first one is from theoretical volume to dynamically spatial reality. The traditional VMS software operates on static volume. It is assumed a pallet is a perfect rectangular box with a defined dimension. If the contents are stacked uniformly or the pallet is damaged, the VMS remain unaware of the discrepancy. The UF advantage is by using depth sensing camera, such a time of flight sensor or LiDAR sensor or UF, perform 3D point cloud generation. They can the actual physical footprint of the inventory, not just the label. This allow on the system to calculate the actual occupied volume versus the theoretically available volume, identifying a dead space. that the VMS previously thought was occupied. And the second is automated detection of dimensional anomaly. In manual environment, measuring the volume of high bay racks is dangerous and time-consuming, meaning it is rarely done until the conflict arises. For example, a forklift cannot fit a new pallet into a slot market available. The UF advantage, because UF can traverse the entire Z-axis height of a warehouse, the conduct volumetric audit as part of their routine flight path. The EI integration compare the current scan to the VMS master data. If the system detect a pallet that is bulging, tilted, and encroaching on another slot, it trigger an immediate alert. This essentially volumetric error detection occurring in real time. And the third is precision slotting and revenue optimization. Volumetric efficiency is directly linked to storage costs. If a VMS believe a slot is 80% full, but reality show it is only 50% full due to poor stacking or empty spaces. The facility is essentially losing revenue and that footprint. So the UF advantage is with the granular data provided by UFs, the VMS can execute a dynamic slotting optimization. The system can autonomously reallocate inventory to tighter configuration based on the true volume of the goods currently in stock. This maximize storage density, pallet per square meter, in a way that is mathematically impossible to achieve with manual cycle count. By closing the loop between the physical state of the inventory and the digital record in the VMS, we remove the assumed nature of your inventory data and replace it with a measure reality. Since you are looking into this, you are focusing on the sensor integration, how to get the depth data, or backend VMS optimization, like how to turn that data into better slotting decision on the inventory. Okay, thank you. This is my question.
Okay, now we move to the last question from Amin Tohari. The question is, what is autonomous system relation with drone, different Islam, Iran, Israel, and the US update? I think what what Amin Tohari means is the relation or the context in the Iran and Israel conflict and the latest updates of the US. Yeah, it's a little bit conflict.
Okay, thank you. In the content of the ongoing 2026 conflict involving Iran, Israel, and United States, autonomous system and drone have become central to military strategy, while public terminology often conflates the two. There is a clear distinction between the mass use of remotely piloted drone and the emerging, more sophisticated autonomous technology currently being tested and deployed. The distinction between drone and autonomous system, it is important to clarify that many drones currently in use are not fully autonomous. Remotely piloted drones. The vast majority of systems, such as Sehat family, loitering munition used by Iran and its proxies function primarily through remote guidance or pre-programmed flight paths. They are often used in large barrages to overwhelm our air defense rather than through intelligent swarm behaviors. And autonomous system or AWS, this system represent a higher tier of technology, capable technology of making decision, such as target identification or navigation, without constant human intervention. While militaries are rapidly accelerating the integration of AI to improve guidance and targeting through intelligent autonomous swarms are still in an early evolving state of combat deployment. And dynamic in the Iran, Israel, and U.S. conflict, the conflict has highlight a significant shift in how these technology are used. Iran's strategy, Iran has relied heavily on counter-air campaigns, combining low-cost drone like the Shahed with a missile to game or overwhelm Israel and use. Air defense system report indicate the Russia has been instrumental in helping Iran rebuild its capabilities, including providing drone component and potentially AI enhanced guidance technology to improve targeting accuracy. And the axis of resistance. Drones have decentralized the conflict. Iran's proxies, such the Houthi and Hezbollah, have gained the ability to manufacture and deploy drones independently based on Iranian design. This has turned the axis of resistance into a network with multiple content of expertise, making it harder for US and Israel to neutralize the threat by targeting a single source. And Israel and US respond. The US and Israel have focused on developing advanced counter-drone CUAS system. Recent US legislative action such FG 2027 NDAA show a massive increasing in funding over $74 billion for drone and counter-drone technology. This includes establishing a new command like the Robotic and Autonomous System Combat Command to better streamline the acquisition and deployment of autonomous capabilities. And the last is technology update and trends. AI integration in technology, both sides are experimenting with AI to enhance drone performance in communication limited environment. This includes improving target recognition and allowing drone to operate even when GPS signal are jammed or unavailable. And counter swarm technology, because defending against large-scale drone attack is economically imbalanced. Using expensive missile to destroy cheap drones, defense company are pivoting to swarm neutralization. Swarm neutralization technology that can detect and engage multiple threats simultaneously at a lower cost. And autonomous logistics. There is an increasing push for autonomous system to be used in contested logistics, where drone move supply to frontline area where human piloted craft would be at high risk. In summary, while the conflict has seen a massive proliferation of remotely operated drones, the autonomous update refers to a nascent but rapid shift toward AI-enabled targeting and swarm management. The US and its allies are currently restructuring their military hierarchy to treat this robotic and autonomous system is a primary pillar of future combat rather than just a tactical tool. Okay, thank you.
Okay, thank you very much. As we come to an end of questions from the participants, thank you very much for your answer, Dr. Migunani, and thank you very much to the participants who's willing to being actively in the Q&A session. Ladies and gentlemen, as we come to the end of today's webinar, on behalf of STEKOM University and all collaborating institutions, I would like to express our sincere gratitude and our distinguished speakers for sharing their valuable insight and knowledge in this intelligent UFA system shaping the future of smart technologies. Before we officially end the event, we would like to invite all the speakers and participants to joining us today for group documentation session. Kindly turn on your cameras, smile, and let's capture this memorable moment together. Please, all of the participants, kindly open the cam so that we could capture the moment together. Okay. Okay, we wait for all the participants to open their cam. Seems okay. Mr. Ferry Kurniawan, Mr. Mohamed. Okay, now for Mr. Abdullah, you can start to capture as I count it from 1, 2, 3. Okay, 1, 2, 3. Last one, different pose. 1, 2, 3. Okay, thank you very much. Thank you, everyone, and thank you, our distinguished speakers, Dr. Migunani. And the attendance
Thank
link has
you.
now been shared in the Zoom chat. Please to make sure you complete your attendance from being before leaving the Zoom. Once again, thank you very much for your participation and support. We look forward to welcoming you to our next future international collaboration. Stay safe, stay healthy, and have a wonderful day. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Miss Gita. Thank you,
Thank
everyone.
you.